Okay, 21st Century Skills, this is your quick run through on the nomenclature or technical terminology for your custom laser branding. So first thing we're going to start with is explaining network. And you've used this already, but network is that whole ability for me to go on the computer next to the laser engraver and click this drop down here and go to my student work drive in that 21st Century Schulte, and I find the same file here that I was working on over there. That's called a networked server, and it's kind of like a common storage location up in the cloud. Another concept for a network is like a community of people who work together or who live together. Inside that community, there's a network. So I might know the guy who plows snow, and if my grandma is unable to get out of her driveway, I can contact him, send him a text message, and he can help her out. So that network allows things to happen too. Okay, other words that you need to know. Oh, datum, yeah. So datum is a 0, point. And on a coordinate grid, this is kind of math stuff. Let me cancel this here. Cancel. Zoom out. What we're looking at here is a straight-on view, or like an overhead or bird's eye, like we're hovering above, of this grid right here. And let me move the laser head out of the way. So our grid here is the same as what we're looking at here. And the datum point is that 0, point that's right in the corner right there, the red dot. So our datum 0, the laser starts out, come on, focus, from that point, and it comes out into the grid somewhere and it then knows where to cut. Now we tell it where to cut by placing art on here or work like this, and then telling it to use absolute coordinates, which means we want you to line up if the front of this spoon, where's my mouse, right here, if the front of my spoon touches like 40 millimeters up here, look at that little indicator that moves back and forth, and if I come down this way and look over here, I can see the one on the left side over here moving up and down. It's like 100, actually it's 183 on the y-axis. That's absolutely where that spoon is here, so we can burn accurately. Now let's talk about the x and y axis a little bit more. This is the same in algebra and math as it is in laser engraving. X-axis runs here, this way, okay? Y-axis is our vertical axis. If you understand coordinate grids, it's like we're in the bottom left corner of a coordinate grid right now with the datum being up here. It's just these numbers aren't negative, okay? So if that makes sense to you. But x-axis is horizontal, y-axis is vertical, looking at it this way, or I should say x-axis is left and right, y-axis up and down. But check this out, z-axis, there's a third, okay? So right now our laser, we can move it on its x-axis back and forth. We can move on it y-axis, coming closer to us or farther away. And watch what happens on those numbers when I do that. Take a look at the y-axis right now. It's at 19.1 millimeters. Now it's at 238 millimeters. So we can see it moving here when I push the button. The last axis that we have to be aware of is the z-axis. So if we do a z move here, let me do an autofocus here. It's going to move on its z-axis by bringing the table up and touching here, and then it drops it back down until it gets exactly where the laser needs to be focused. Okay, so that's z-axis movement right there. Another one we wanted to talk about is print target window. So if we look at our spoons, the ones we've been using, we're going to use measurement for our custom print target windows that is metric. So in this case, we've got a ruler. We probably understand standard inches. They're upside down and start right here. 0, 1, 2, 3. We're going to flip that ruler over and use metric centimeters and millimeters. And actually millimeters, this would be 10 millimeters, 20, 30. And our print target window is basically what size of a window do we have to print on that our artwork would fit into. So in this case, I would estimate about 65 millimeters, maybe 70 if we really stretched it. And if we went this way, I would probably be 35 millimeters wide. But it's an ellipse too, so I have to factor that in. So what I did was draw an ellipse here, and if we measure that on the screen looking at the coordinates, the bottom of my spoon is at 215, 218. If I go up to the top and use 215, I'm at 158 for millimeters. So that is a difference of about 55 millimeters across. So my spoon is actually drawn a lot larger than the art is, which is maybe some of the problem why we've been running off the edges of the spoon in these initial drawings. Okay, just a few more concepts. The print target window is important because when you do your own custom artwork, let's say I wanted to do some laser engraving on the back of this remote, you're going to have to measure a window that you want to print in. So clear, clean windows here, there's kind of a lot of stuff in the way. If we were going to measure a really small one, we could measure right here and say I've got a 30 millimeter by 20 millimeter print window right here that I might be able to use. But that's my print target window that I want to try to put my art inside to fit into. And so I would have to build a grid or a print target window out here that is about that same size, 20 by 30 millimeters. I could do a square like this, a rectangle. And then what I would have to do, oh, I missed the click. Let me click here once. Rectangle. So if I start from the 0 point, I'm at X 106 in the bottom right corner. Go all the way over to minus 30 would be 76, and then up 20. That's about the same print target window that I would have on the back of that remote. Okay, last two things are travel speed and engraving power. So travel speed is really how fast this moves in millimeters per second. Now normally it travels a lot faster here when it's just moving across the table, like bed travel, but how fast it moves when you actually do a laser engrave is controlled right here in speed in millimeters per second. So the travel speed is measured in how many millimeters it will move back and forth in 1 second. And we can go up to about 300, and we can go way down to like 25. The other one is the power of the laser, and this would be in percentage between 1 and 100. So 45 is just about half power for the laser. The more we turn the laser power up, the deeper it burns. The slower we let it travel, the deeper it burns. Because if the laser is contacting the material a lot longer or shooting a lot longer at one spot, it's going to burn a lot deeper than if it's going back and forth and only contacting it for a very short amount of time. So from this, we got through the basics of technical terms for the laser engraver.